everyone, my name is KyiCinLinHtut and this is my Unit 4 mid-unit assignment. So in this video, I will go through 3 questions. One is about the average temperature. Another is about the Ferris wheel. And another is about the tide problem. So let's look at the first one. In the first question, we were given the average temperature. So here we have this graph, or here we have this chart. What I first do is that I turn these months into numerical numbers, which is 1, 2, 3, 4, 5, up to 12. It wants us to know that it wants us to determine the trigonometric equation that models this information given above. So for this solution, I use cosine function model, which is y equal to a into cos y equal to a cos b into x minus h plus c. And from the graph, we can see that the maximum point was in January, and we can also look at the chart, which is minus 24. So we get the minimum value. And then for the maximum value, we also do the same. The maximum is in July, and the July, if we look at it here, its maximum is 21. So from here, I use the general formula, which is if I want to know the amplitude, I have to subtract minimum from the maximum value, and I have to divide it by 2. And this is what I did, and I substituted these values, and I get 22.5 as the answer. And for the vertical shift, or some people sometimes call midline 2, the general equation is maximum plus minimum by 2. So I use that equation, substituted it, and I get minus 1.5. So now I wrote period t equal to 12. But the reason why I wrote period t equal to 12 is that period means the time period before the cycle repeats again. And for this average temperature cycle to repeat, it will have to go through January all the way to December, which means it takes 12 months, which is why here for the one cycle to repeat, period is 12. And from the period, I write the I also use the general formula, which is if I want to find the b, it's 2 pi by t, and t is 12, so I substituted t into here, and I get pi by 6 for the b value. Now we can see that the graph, so this is the cosine graph, it shifted to 7 unit, which is in July. Because as we all know, the cosine graph, it starts with the maximum point. But we can see that if it actually started with the maximum point, it should start here. But it did not start there, but it started here, which means it's shifted to 7 units because July is 7, and from these numerical values, we also wrote that July is 7. So the horizontal shift becomes 7. From all of that, I substituted all the numbers into these alphabets, and I get the equation that the first question asks. Now this is the second question. It's the Ferris wheel question. So here there's some facts given about the Ferris wheel, such as the diameter is 10 meters and it takes 24 seconds to make 1 revolution. It also says that the lowest height on the wheel is 1 meter above the ground. Okay, so the question A says sketch a graph to show how a rider's height above the ground varies with time as the Ferris wheel makes a rotation. And assume, this is important, assume that the person starts at the right at the lowest point on the Ferris wheel, so it starts at the lowest. First of all, to actually see the question, I drew this picture because from the given facts of the questions, I get the diameter is 10 meters, which means if we divide it by 2, we get the radius, which is 5 meters. And then we get 1 revolution equals to 24 seconds, which is also given in the question. From here, we can draw this picture, which is please pretend that this circle is a Ferris wheel, and the Ferris wheel is 1 meter above the ground. Now its diameter is 10 meter, and its radius is 5 meter. Which means here's the statement that I drew. So we know that the revolution, after 24 seconds, it makes 1 revolution. Then the person starts at the lowest point here, which means when the person is at 12 second, which is the half of 24 second, the person will be at the highest. And just like that, we can also divide the 12 second by another 2, then that person will be halfway to the highest point. And then the Ferris wheel descends again, and at 18 second, they will be halfway to the lowest point, and that's how they make the 1 revolution. So 24 second, they return to the lowest point. Okay, so from both this statement and from this picture, I made this table, and here I wrote time, x equal to time, and y equal to height. Here I graph the same, I wrote down the same time that I talked about in this graph, which means 0, 6, 12, 18, 24. So actually, for the Ferris wheel to be at the highest point, the Ferris wheel highest point should only be at 10 meter, actually. But because it mentioned that the Ferris wheel is 1 meter above the ground, which means that 1 meter is also fixed. So we have to add 1 meter to all of the values that we get. So when it's at 0, it's not moving. So it only has this initial height, which is 1 meter. At 6, it should be here. At 6, it should be right here. So which means it's gonna be like the radius. So it has to be 5 meter, but since it's 1 meter above the ground, it's 6. The same thing goes with the 12 second. The 12 second, it should be that at the highest point, but the highest point, the diameter is 10 meter, but at 1 meter, it is gonna be 11 and so on. And from here, I could graph the graph based on this table. And this is what we get for that. Now let's go back to the question, and it says, write a trigonometric equation that describes the graph. Okay, so to write the equation, we know that the maximum is at 11 and the minimum is at 1. So that's what I wrote, and then I also used the cosine function model here. Amplitude, I search for it. Period, it takes 24 seconds to make 1 revolution, which means it takes 24 seconds before the cycle begins again, which is why I chose period equal to t equal to 24. From the period, we can calculate the b, and we get the b, the result for b. And the vertical shift, which is c, or we call this midline, it is maximum plus minimum by 2, so we get 6. Now, there's 2 ways to actually calculate this. One way is pretending that this graph is not actually reflected, but it just shifted. If it actually shifted, then it would shift to 12 units, which means the horizontal shift h would be 12 units. But for me, I find the reflection method a lot more easier. So instead of assuming that this is where the graph really starts and it's just shifted, I assume it as the graph somehow reflected. So I don't use the horizontal shift method anymore, and I use the reflection method more, which is why I wrote, since the graph is reflected on the x-axis, A is negative. So when I substituted all of these numbers into the alphabets, I wrote -5 because I treat the graph as it's shifted, because as we know, cosine graph has to start at the maximum, but this started at the minimum. So I assume that it was reflected. For the C, it wants us to know the accuracy by using t equal to 12 seconds, which is what we did. T equal to 12 seconds, which means I substituted 12 to all the positions of t and I get 11. Let's see if the answers match. At 12 seconds, the height is 11 meters, so it matched. That's why on the graph, the maximum height is 11 meters when t is equal to 12 seconds. Therefore, the equation is accurate. To make sure the equation is extra accurate, I even added 0 and 24. I substituted it. I get 1 meter and 1 meter each. I'm sorry for this. This is because I couldn't see it properly, so I had to rewrite it over it. So at 0 and 24, as we know, 0, the Ferris wheel is not moving yet, so it only has the initial height, which is 1 meter. At 24, it has come to a stop, which only has the initial height, which is 1 meter. So the equation is accurate. Now for number 3. Okay, it gives us these given. So it says from a low of 4.5 meter to a high. So which means I use the reflection method. And I started my graph at minimum, but we'll see it later. Anyways, so we get these as given, and it's also measured with 24-hour clock. Okay, so assume that the height of the tide-giving model is a cosine function, which means it asks us to model it with the cosine function again, and it even gave us the cosine function, so that's what I used here. Now from here, I know the minimum height and the maximum height, and I also know 2 time intervals. And because I want to make it easier when I calculated them, I make sure that all of the units are consistent, which is why I choose this. I turn this into hours. So it's 2 plus 8 by 60. The reason why I do 8 by 60 is because 8 is minute. In order to turn the minute into hour, then I will have to divide it with 60 because there's 60 minutes in 1 hour. That's what I did. From the maximum and the minimum, we get A and C and their respective values. Okay. Now, the reason why I multiply period with 2 is because if we take away 2.13 from 8.35, we get 6.22, and that's half one full cycle. So in order to have one full cycle, we have to multiply with 2, and which is why I did this. And this is what I get. So when I get the period t, I can calculate the k. So I added them into the general equation, and I get this value as k. Now again, remember when I said I will use reflection method? So because I assume that this starts the tide starts from minimum, I choose the time that it started as minimum, which is why I choose d equal to 2.13 instead of this one. And from here, I get the equation for it, but like I said, cosine graphs has to start at the maximum, but I started at the minimum, so I added minus in front of the graph, in front of the A, and I substituted 2.13 into the D. That's how I get the equation. Now for this, yeah. Now for the C, I want to know determine the height of the tide relative to the pier at 11:30. So I first turned 11:30 into hours, and I substituted 11.5 hours into the position of T, and this is what I get. Well, 10.77 meter, but it wants me to round it up to 0.1 meter. So this is what I get when I round it up to 0.1 meter. Okay, so this will be the graph because it says the boat needs at least 12-meter depth to dock at the pier, and it wants me to use a graphical approach. So for this graph to happen, I plotted some of the points here, and I just plotted these points on this graph too. Here we can see that, okay, let's zoom in. It's a little bit over 12 when the time is 5.6 hour. Because this is 5, and then this is half of 5, so this would be 5.6 hours, and if we go up, there it is. So the same thing happens at 11.1 hour. Which means at those time, the water is, above 12 meter, or at least it's at least 12 meter. But here, it's even a little bit, very tiny bit greater than 12 meter. So from that, we came to the conclusion that from the graph h of t is approximately equals to 12 meter when t is equal to 5.6 hour and t equal to 11.1 hour. So I converted them back to hour and minute. And of course, because this is a cosine graph, so it's gonna go a long way, but I just do this graph for this one section. And in this one section, we can see that the boat can dock exactly at not exactly, approximately at 5.6 hour, which is 5 hour and 36 minutes, so 5:36. And it can dock all the way to here until the water will be descending. So at 11.1 or at 11 hour and 6 minutes, the boat should leave because it can no longer be docked, and the height of the tide will be less than 12. And this is it for my Unit 4 mid-unit assignment. Thank you so much.